Hi class, it's Bill Berry back with another video for our Java 2 series. In this week we are starting to look at some new data structures, stacks and queues, and for those who are in the physical class with me, we're going to be looking into some things that are involved in the final project, or would have been if we don't have time to get to that, including mocking and timers. May or may not be videos for those, but doesn't matter. Stacks and queues are the important things here. So let us jump in. So these are common data structures. You'll see these used a lot in computer science. We'll touch on a couple of ways that they can be used in some technical ways, but they are typically built on very simple things, right? They are implemented based on technology that is very straightforward, like a linked list, right? We don't really need anything too fancy to make these go. So these are more conceptual. We won't talk as much about the code because we know a linked list would do the trick. So what are the basic things here? Well, these are linear data structures. So they are going to be an ordered sequence. But unlike an array, they are not meant to be accessed randomly. They have a very specific number of things that they can do. In fact, by design, they are very limited in what they can do. So very few methods. You've got to have some way to add something to the list and remove things from the list, although that gets interesting because of the way you have to do it. Probably want to know whether there's an empty list, whether there's anybody in there at all. And then sometimes you'll see a size method, may or may not do that, because if you know it's empty, then maybe that's what's most important. Size overall may or may not be important. Also, peaking is one of the things that you want to do here, because the normal operations will remove things from the list. And so peaking means you want to take a look at the thing that's at the proper end, the next thing that you're going to act on without actually acting on it. So that's a very common thing that we're going to see. And you'll actually see that idea implemented even in Scanner, where you can say, hey, is the thing that is next in the queue, does it has next an integer, right? So you can actually look at whether there is a next integer there before you actually pull it off. So that's an idea of a peak. Now, again, notice that what the methods that are not typically provided, in fact, they sort of go against stack and queue usage. You can't get to things in the middle, and they don't really provide a way to traverse, right? The idea is not that you traverse these lists at all. You act on them in a very specific order. You don't do traversals. So let's first look at stacks and see what they are. The idea of them is very straightforward. It is an ordered collection, of course, and in this case, this is going to be a last in, first out access. Now, some of you will think of it or have heard it backwards, and instead of LIFO, you will have heard FIFO or a FILO, but however you want to think of it, it's last in, first out. So the way that I think of these is the trays in the cafeteria. I think this is a great analogy. So when you go and get a tray in the cafeteria, the tray that you pick up is always wet. Why is that? Well, when they put fresh trays, when they've washed them and they come dump that stack on it, they put them here, right? It is a stack of trays. So the new trays that are washed get dumped at the top, and the one that you are going to touch is in fact that top one. So you always get a wet one because this is a stack. So by nature, the last tray that was put on here is the first one that comes out, right? The last clean one that gets put on here is the first one that's going to be taken by a customer, right? Somebody who's eating. So that is a great analogy for trays. Now, these have very specific terminology associated with them, and you'll see this when we've talked about computer memory and how the stack is used in computer memory, right? The program or the stack that is used by the computer to store function information works in this same way. Even though we're not talking about using it and using the stack that way, we're going to create a separate data structure, but the idea is exactly that. But the terminology is that you push something onto the stack and you pop one off. Maybe you can think of this analogy. Sometimes at the bottom of this thing, there's kind of a springy thing that pushes up so you don't have to reach way down. Oh, so you're sort of pushing down. You're actually making the whole thing get heavier and pushing down. And then when you take one off, it kind of pops up. The whole stack maybe pops up because it weighs a little less. So if you think of a spring mechanism down here, sometimes that may help the pushing and popping idea. And again, we're going to focus on these as data structures. We're not going to use the traditional function stack that the system sets aside. We're not going to use that for our purposes other than, the normal ways that we use it in programs. It's not that stack. This is a data structure that we're talking about. So if you want to do a stack in Java, how can you do that? Well, there is a generic stack class, so you can use that. Remember, you can also do a linked list. When we use it in our projects, we're going to do stacks and queues as our own little linked list. So we're sort of building our own. But there is a generic stack class, and generic means it takes a type parameter, right? So when you create one, you're going to put in angle brackets, the thing that you're making the stack out of. What is the strong type of the items that are going onto that particular stack? Now, it does a little different implementation. It extends the vector class, which is not implemented as a linked list. It doesn't really make any difference. If you're going to use theirs, you use theirs and it'll work fine. Now, the methods are very limited. As we've said, stacks and queues by nature have very few methods. And so here literally are all of the methods in that stack class. You have a way to find out whether the thing is empty. You can peek at an item without acting on it. You can pop one off, removes that top element. You can push one on, and this one may be a little bit unusual, maybe atypical for a stack. You can also do a search. But if you think of it, the way that it does the search, if it's really doing it in a stack form, it literally has to pop them all off and push them all back, right? There's no way to cycle through a traditional stack. So if it really implements it in a true stack fashion, or if you were having to implement search yourself, you're not supposed to traverse the list, even if you've implemented it with a linked list. You're supposed to pop them all off and push them all back, right? Save them and push them all back. That's the only way you could really do a search in true stack form. Now, there's also a fancier one. There is a DQ interface, which extends queue. So you can, in fact, use that interface, and it has a lot more, right? It interacts at both ends, and it has a lot more methods. But really, this is kind of what we want when we're learning stacks. We really want kind of a basic set of methods so that we can really exercise our brains in a true stack context. So where are these used in computer science? Well, all over the place. Of course, when you're working in computer memory and when you're writing functions, you are always using function calls, and of course the system has a stack that does all this. It's a limited amount of memory. It's not a data structure that we tend to mess with, except that we let it do its thing. But when you're doing languages and compilers, you might want to stack in order to evaluate expressions, and we're going to look at an example of that. So we have the traditional computer memory stack, but languages and compilers may often find useful ways to do that, and we're going to see it in a minute. So also, if you think of matching up related pairs of things, you could find out whether a string is a palindrome using a stack, where you can push things on and pop them off and see if the order is identical in both directions. You can all sorts of things. Oh, infix and postfix and prefix, like different computer science ways of expressing things can be converted sometimes using a stack. And by the way, some of the stuff that we've used recursion for, like searching, traveling problems with backtracking, you can use a stack to do that. So instead of using the traditional stack using recursion, you can actually make your own stack, which turns out to be kind of ugly, right? The reason that we wrote our recursive code is because it was elegant. So you can write around it with a different approach, and you can use stacks, but it's ugly, right? You are definitely doing a lot of work yourselves. Also, a lot of programs have undo, right? And if you look at Microsoft Word, for instance, there's an undo stack where you can undo just the last thing or the last two things or the last four things, and it will go back through that and undo them up to that point. So stacks are super useful data structures. One thing that's fun to do here, this is a very typical computer science-y thing to do, is you have to, if you're parsing an expression, if you are parsing a programming language, and especially if you're parsing an expression here particularly, how are you going to write code that evaluates these things? So let's say we have a super simple language syntax that requires parentheses for everything in essence, right? Any kind of sub-expressions. We're not going to do order of precedence. That's harder. But if you just wanted to evaluate an expression, let's just say that this particular language requires parentheses around every operation. So in this case, we're going to evaluate this whole thing. And how would we write code to do this? So one way to think of it is you would have to parse this. Now parsing isn't as simple as splitting because these are not split just on spaces. We want to be a little more careful than that. We want to have to walk through very carefully and note the difference between a symbol and a number. So we have symbols like that and that and that and that, right? So we have a lot of symbols here, but then we also have numbers. So if we parse it, we have to look carefully for what's the difference between whether we've hit a symbol or a number, and then we're going to make two different stacks. We're going to have one stack for the symbols, and we're going to have another stack for the numbers. And as we find new things, we're going to push things onto the stack. And as we resolve things, as we know we can finish them, we're going to pop them off to remind us that we have consumed them and we're done with them. So how might this work? Let's look at a super simple case where we're just doing something like this, right? Parentheses 2 plus 3. So you start with the symbol stack being empty and the number stack being empty, and I'm just showing symbolically what these would contain. So when we see the open parentheses, we say, oop, we have a symbol. So we push it onto the symbol stack. So now the stack has that. Then we move on and we see, oh, we've run into a 2. That's a number. So we push it onto the number stack. So now our symbol stack has that, our number stack has that. Let's say let's just work in doubles for now. Then we see the plus and we say, oh, another symbol. So we push that onto the symbol stack. So now the symbol stack has that, and the most recent one was the plus. Notice it's a stack. Okay, then we see the 3, and we go, oh, that's another number. Let's push that onto the number stack. Now here comes the big moment. When we see the closed parentheses, we know that an expression has to be evaluated. We know that the closed parentheses indicate that there's something that needs doing. So what do we need to do? We pop off the most recent symbol, and we say, oh, that's a plus, right? We know that we're going to pop off that. We know that the most recent thing has to be an operator. We know that operator is going to act on two things because we're not talking about unary operators here. So we pop off the two numbers, which is the 2 and the 3. We then write code that says, hey, for that operator and those two numbers, I need to add those two things together. I calculate the result, and then notice I have popped that off and I have popped these off. And in fact, I can actually pop that off too at the end, right? Because I know that's the starting point, but I've already finished it. So I've calculated the result. I then push that back onto the number stack. So now I have the 5, and I know since I finished this operation, I can also pop off that parentheses. So now after this little expression is evaluated, I have nothing on the symbol stack, and I have this 5 on the number stack, which I hope that you can see. You could also then, if you had started with one of these, you could also have, times 8 or something like this. And that would then be able to be the start for the next thing, because then I would run into another symbol, and then I would run into another number, and when I hit the close, I know I would have to do one more thing. So you could think of writing this expression evaluation code using recursion, but you can also think of it as if you used a stack, right? So stacks can be used, and a lot of times they are interchangeable with recursion, and depending on what your particular needs are, one or the other might make more sense. So that brings us to the end of what we want to talk about in terms of stacks. Again, not going to talk a lot about code because the implementation of them is really not very exciting. You can imagine so easily making a linked list. For some of the stacks and queues exercises, it's useful to have an end pointer, right? Because on the stack, it's always going on the front, but on the queue, you're gonna need to go at the other end. So, but for a stack, really a traditional linked list is so easy to implement, and you can see exactly how you'd implement all of these methods that we've talked about. So I think we're going to stop there, and then we'll come back and talk about queues in a minute in a separate video. But thanks for watching this one, and see you back in the next perhaps.